Yeah. So now we are going to see what is a cap theorem. Right? Cap theorem. So in one line we can say that it is a distributed property. It is a distributed property. It is a desired property of a distributed system with repeated data. So what I had said right now, that it is a sorry, it is a de- it is a desired property so what I can say is okay, so now we will see what is cap theorem, right? So let's say cap theorem is nothing but cap theorem is nothing but it is a the desired property of distributed system with replicated data, right? So it is a desired property of distributed system with replicated data. Means we only deal with this with only come to a conclusion whether to use a cap theorem or not in a distributed system with a replicated data. So now let's see what does this thing stands for. C, A, and B. Now C stands for consistency, A stands for availability, and P stands for partition tolerance. Okay, stands for partition tolerance. Now let's delve into example. See what is cap theorem. So design a node. Let's design a few nodes. A, O. Now this is a node A. This is a node B. This is a node C, and this is basically the application. This is a DB node. This is also a DB node. Okay. Now, for example, this node is in US, and this node is in India. Right. Now, and one more thing, that as we have already said that it is used in a replicated data. So B, comma C has the replicated data. Okay. Now, one more thing we study that in in cap theorem, either we have consistency and availability, or availability and partition tolerance, or consistency or partition tolerance. Okay. But all three together is not possible. Right? All three together is not possible. Now, why I am saying this? Because let's see with an example. For example, let's say that we are having A. This is our A node. This was our so this was our this is our, I can say, C node. This is what the structure we are talking about. So for example, let's say it is a DB node. There was a variable which has a value, which had a value 5, and also that variable in this DB node also had a value 5. Now let's say that application, this was the application, right? This was our application. Now this application has changed this value to 6. So what this DB node will do, it will also change this to 6, and it will then connect to this DB node, and it will say him that now remove this value and put this value as 6. Okay. Now, so this thing is known as consistency. This is known as this is known as this is known as consistency. Means uh, the variable will have the same values across all the dimensions. Okay. Now, let's see. So now just see what is availability. Availability. Now availability means all the DB nodes, are, so all DB nodes should respond when Asian. Okay. Now the last and the most tough, or I will say the most difficult thing to understand, but I will make it easy, don't worry. So the last but the most difficult thing to understand was the partition tolerance. The the partition tolerance. What it says that, look, for an application like this, for example, this was the application. This application doesn't know how the database is giving it the query. Like we have B here, we had C here. Okay, now this is the, sorry, I can just go back. So look, this application as a whole connects to this database, and this database nodes, and this database nodes decides from which the response will go. Right. So for example, partition tolerance. Partition tolerance means even after the partition happens between these two nodes are also connected. Even after when after there is a partition in the AV nodes, the system should give correct result. Right. So these are the basic definitions. Now let's see so what are the possible that we already discussed, that either any two of those things are possible and all three are not possible. So let's see how this happens. Okay. So now let's see. So now let's see. So what are the possible conditions? Possible conditions are either CA is possible, or CP is possible, or AP is possible. Okay, but CAP is not possible. So let's see how. So these are our nodes. Okay, let's say this has a value is equals to 5. Sorry, it's equals to 5. Now, consistency means that all these nodes will have the same value. Now let's see. Look, A is equals to 6 done by our application. So this will also change this value to 6. This will contact this, and this will also change the value to 6. So now availability, so consistency done. Okay, now availability. Availability means if it will query what is the value of A, then this node and this node is ready to give the value and it will get the value 6. Right? Now let's see partition tolerance. Now if I have a partition tolerance, right, and for example this the connection between these two nodes is great. Okay, right, partition tolerance means even if there is a partition, the system should get a valid result. Okay, so now for example let's say the value is changed to 7. So this value is also changed to 7, but this will not able to connect this because there is a partition between these two. Okay, and it will have the value 6. And for now if this value varies, then it either gets 7 or either gets 6 depending on the location. So we can see that it is having availability also, partition tolerance also. Partition tolerance how? Because it is getting a value, right? It is not that it is not getting a value, but consistency, that consistency is destroyed. It is holding the value as 7, but it is holding a value 6. So this is consistency got destroyed. So these things we have to do. Right. Now let's see how consistency and partition tolerance is, uh, how we can get consistency as well as partition tolerance. Okay. So since we can neglect the availability, right? In this example only, if we see that the similar things happen again. But what we can do now, that this node we can just down this, for example this node is down, it is not responding anything, right? So now if there is also, if there is a partition also, so it will not able to get the value, it is down, but it's okay, it's okay, because even after this application will query something, it is get, it will get the value from the node key, because it is already down. So we can see that consistency is gained here, that we are having node C, partition tolerance also gained, even how, that if there is a partition but we are getting a valid result, right? So we can see that CP is possible. Now let's say how CA is possible, means we are neglecting the partition tolerance. Okay, so how we can do that is, for example let's say we are having consistency, means all these value will have the same, all these nodes will have the same value, all nodes are up, but partition tolerance is not there. So if there is no partition tolerance, right, partition tolerance means even if there is a partition, there is we will get a valid result. So this is partition tolerance is not there, so this is a partition, and this अगर partition हो गया तो system deliver सिस्टम